outside, inside, on, which is on the actual just line that makes a circle. All right, so there are three kinds of lines or segments that interact with a circle. The first one's called a chord, and a chord actually has its endpoints on the circle. It doesn't go outside it, doesn't stop before it gets to the edge. It actually, their two endpoints are on the circle. A secant is a line, so it goes in both directions forever. It's a line that crosses through the circle and intersects the circle in 2 points. So like it goes in here, through the circle, and out that side, and it intersects the circle in 2 points. And a tangent line is a line that touches a circle at 1 point. Okay, that's what tangent means, right? It touches something at 1 point. So, and that point where it touches is called the point of tangency. Good. So, I have to record that. So, all chords, or all diameters are chords, but not all chords are diameters. All right? Now we got 3 more vocabulary words about circles. All right? We have a biconditional statement about congruent circles. 2 circles are congruent if and only if they have congruent radii. So remember with biconditional, you can read it either way. So you could say if 2 circles are congruent, then they have congruent radii. Or you could read it if they have congruent radii, then they're congruent circles. So as long as you can show that these 2 radii are equal, you could say the circles are equal, or if you already know the circles are equal, you're allowed to say the radii are equal. So that's kind of and that kind of makes sense, right? Because the formula for the area of a circle is pi r squared. It's just the radius is the only thing that affects the area. So if the radiuses are the same, the area has to be the same, so they'd be congruent. All right, and what's coplanar mean again? On the same plane, good. Concentric circles are coplanar circles with the same center. So that just means you can't have 2 circles that like one fits inside the other, because those would not be on the same plane. One would be going this way and one would be going this way. So concentric circles are coplanar circles on the same like piece of paper that have the same center. And the last kind of circles are tangent circles. And tangent, just like tangent lines, tangent circles touch in exactly one spot. So we can have tangent circles that are tangent on the outside like this, or we could have inside tangent circles that are tangent at 1 point but inside the circle. And you'll notice the centers aren't at the same spot. So they're not concentric, they're tangent. What would be the only concentric? And then let's do a little work with the coordinate plane here. So what kind of circles are those? Tangent circles, concentric circles, or equal circles? Tangent. Okay? The way we can prove they're not equal, because they could be tangent and equal, right? Or they couldn't be concentric and equal, but they could be tangent and equal. So how could I prove they're not equal? They have, yeah, just show the lengths of their radiuses are different. So what's the length of the radius of this circle? Yeah, 1, 2, 3, 4. So the radius of this circle is 4. And what's the radius of this one? 1. Okay, they're tangent. That means they touch at one spot. What is their point of tangency? Good, 2, -2. Over 2, down 2. 2, -2. And if I were going to draw a line that's tangent to both circles that goes through the point of tangency, that would be here, right? Okay? What kind of equation, or what kind of line, what's the equation of a line that is horizontal like that? X equals or Y equals? Y equals, good. Okay, and Y equals what? -2, good. Because you can do, like, if you were doing this point, it'd be -4, -2, -2, -2, 0, -2, 2, -2, 4, -2. The common thing is they all have a Y equal to -2, right? So no matter what X is, Y is -2. All right. And then we have, last time we had circles that were tangent to each other. Now we have two circles that are tangent to the same tangent line, and we call those common tangents. And there's internal and external. An internal tangent line is a line that if you connect the centers of the circle, an internal tangent line would cross it. Okay? Whereas if I connected the centers of these circles, see how the external tangent lines, they wouldn't cross it, right? They'd be on the outside. There's two different ones. They don't have to be, there doesn't have to be two. I just gave you two different kinds. Does that make sense? Internal crosses that line that connects the centers. External doesn't. All right, now we get to the meatier part of tangents, stuff we can calculate with and things. All right, and this is the relationships of radii and tangents. Okay, so the first theorem is if a line is tangent to a circle, just like this line L is tangent to circle A, the line is perpendicular to the radius that you draw to the point of tangency. So that means if I've got a tangent line and I draw a radius to the point of tangency, that is perpendicular. That those two lines will be perpendicular. And the inverse is also true. If I have two perpendicular lines like this, then the line on the outside is perpendicular to the radius. I just said that but the same way. If you have two perpendicular lines, then the line is tangent to the circle. So you can say, if this is tangent, then the two lines are perpendicular. And we can say if the two segments are, one segment and one line are perpendicular, then the line is tangent. Okay? So if you draw a radius to a point of tangency, the tangent line and the radius are perpendicular. And last, if you draw two tangent lines to a circle, I call this the ice cream cone theorem because doesn't it kind of look like an ice cream cone? If you draw two tangent lines to a circle from the same point, they both have to start from the same point, draw it out, okay? Then those two segments are equal. So it says if GH and KH are tangent to circle F, remember circles are named by their center, find GH. Go ahead and do that real quick. Oh, shoot. All right, we'll pick this up tomorrow. Don't forget, Schoology quiz, your unit circle quiz tomorrow.